right, so let's start solving the question from complex number. So in the question from exercise 1.1, we are supposed to represent all these complex number in a plus ib form. So this is our first question. In this, we have got to multiply 5y into minus 3 by 5y. So what will happen here is this is a simple case that first I'll have to multiply 5y with minus 3 by 5y. What I get is 5 and 5 gets cancelled, and then I'll get minus 3 times, and then I get I square, right? Now we know that what is the value of I square, that is minus 1. So I'll get minus 3 times minus 1. So because of which I get a 3 over here. So which is a pure real number, but I'm supposed to represent it in form of a plus ib. So what I'll do is I will write it as 3 plus 0 into y. All we are doing over here is that we are just representing it into a plus ib form, wherein your a is a real number, which is 3, b is also a real number, which is 0. So this is what is your first question. So let's try looking at the second question as well. So this is my second question. This is I to the power 9 plus I to the power 9. So in this question, what I have to do? First of all, I have to know the cyclicity of I. So this is something which we have to know. We know that I to the power 1 is actually I itself. Then when you have I square, that would be actually equal to minus 1. Then your I cube is actually going to be equal to minus I. And then I to the power 4 is going to be equal to 1. And it is a cycle which repeats. Like again, you get I to the power 5, which is going to be equal to I to the power 6 is going to be equal to minus 1. And then so on and so forth. And I to the power 8 is going to be equal to 1 again. And I to the power 7 is going to be equal to minus I. So what we will do is we will put this in form of I to the power 4. And then so and that is how we will do. So this will be actually equal to I to the power 8 into I. I can write this like this. And then I can write this as, also I can write this as plus I to the power 16 into I to the power 3. So why I'm doing it is because I to the power 4's multiple will become 1. So this will become 1 into I. And then this will become I to the power 16 again will become 1. And we know that I to the power 3 is actually equal to minus I. So this will become minus I. So what you got is I and minus I, and you got a 0. Now this is a 0, and you got to represent it as a plus ib form. So you will write it as 0 plus 0 into I, and that is what will be your answer. So 0 into 0, 0 plus 0 into I will be your answer in this case. So I to the power minus 39. So same case as in like we will try to first put this as maybe 1 upon I to the power 39. So this is what is one of my property, that if you are having a power like this, a to the power minus b or whatever it is, then if you bring it to the reciprocal, this will become positive. So this is what I did first. And then next I will try to change this into I to the power of 4 into something. So this would be something like I to the power 36 into I to the power 3 I can write. So I to the power 36 can be again written as I to the power 4 to the power 9. And then this I cube can be written as minus I, which we showed over here. Now, I to the power 4 will be 1. So 1 to the power 9 will be 1 itself into minus I. We have got. Now, this is in your reciprocal. So why we would actually try to multiply it by this. Let's say you could multiply with minus I or I anything. So let's multiply with I itself in the numerator and denominator. So what will happen? This will become I and this will become minus I square. And I is fine, but what will become minus I square is minus 1 into minus 1, which will become plus 1 here. So this eventually will become I itself. Now I've got I, but I want to represent it again in a plus ib form. So what I can write as my real part is going to be 0, and then imaginary part is 1. So 0 plus 1 into I as well I can write, or I would, even if I write 0 plus I, it is also fine. So A plus IB, which they were saying. So you could write it this way as well. So this is what is your third question. All right.